Hello. Now we are going to demonstrate the experiment by using RF spice for the power divider. This is a power divider is a popular RF passive device. Basically, this is the microstrip line, and this is a three-port power divider. There are so many types of power divider like resistive power divider, like Wilkinson power divider. So equal power divider means the 3 dB power divider we are going to demonstrate. In this experiment, we are the design step is calculation of the width of power division. Means this basically width is different than this. This width we have to calculate according to some kind of impedance that we are going to see. And secondly, the length of the power division arms. This length we have to calculate between these arms, and here we have to connect a 100 ohm resistor between these two arms to get the better isolation between these two ports. In this experiment, we are going to observe the time domain analysis of power divider, then amplitude and phase at the power division arms between these two arms, and then power division between port 2 and port 3. So how their phases are there, how the amplitudes are divided, that we are going to attend. For the equal power divisions, also we are showcasing the unequal power division between these two arms. Then the last but very important, that effect of power division on the pulse signal. Generally the continuous signal is there, then there is an output is in equal amplitude, so there is no the clear signal clarity is very good, the integrations is very good. But if you are giving some kind of pulse in the power division, what is going to happen at the other ends? Even the division, power division is text plus, but at the same time your square wave pulse is not in the square wave pulse, it is something else, and that we are going to demonstrate in the this our experiment. In the second, we are here writing how Wilkinson power divider is very good. Basically, it is a three-port network condition, lossless and reciprocal matched. Therefore, Wilkinson divider is the best choice in the above comparison. And where the Wilkinson power divider is employed, it is employed in the most of the wireless communication circuit, for the in the power amplifiers, vector modulator, mixer and phase array antenna and linearizer. The Wilkinson power divider is used. There is a three important characteristic is there. Equal amplitude should be there. Zero phase relation between two output signal means there is no output phase shift should be occurs, and highly isolation between two arms of the power division, and the insertion loss is less than as 3 dB because of the equal power division. If you consider the design steps, you can consider this is the input side is coming, this length is lambda by 4, having the impedance 2 into z0, root of 2 into z0, root of 2 is 1.14, z0 is a 50 ohm, that's why you are getting 70.71 ohm impedance over this line. So you have to, our job is to calculate the impedance width of the power division arms for the 70.7, and the length of power division arms is actually a guided wavelength divided by 4. So this length is divided by 4. This length and this length is not mandatory, and the compulsory things is there. You can for your connectorization you can keep is 10 mm or 20 mm as per your choice. We are designing the steps on the frequency 2.4 gigahertz, considering the FR4 material with the 1.6 mm thickness. So now we go to first calculate the mm, length. This is the 1.6 mm thickness, 4.4 is the dielectric constant, then loss tangent 0.09, 3 mm, this is 0.05, and frequency is 2.4, and say compute. So when we compute, that is then a 68.54 is the guided wavelength for the 50 ohms impedance, but we required a 70 ohms, so 1.6 okay, 71.07, so we required little bit lesser, so that is an 70.8. So 1.61 mm strip width we required for the power division, and the guided wavelength is almost 68. So if we go in the this side, we are getting the width almost 1.61 mm for the width of the arms. So this width of the arms is 1.61, and your guided wavelength is 68 divided by 4. So it is equal to again a kind of 17 mm. So 17 mm is the basically the length comes start from this point to this point, the 17 mm length and there, and width is 1.61 mm. So these are the design steps what we've seen in this by using a small calculator. So now we are going to see the actual demonstration of the RF spice. Uh, by using RSpice, the demonstration is we are going to conduct for the power divider. Now Vivek is going to tell you how to simulate the equal power divider, unequal power divider, and if the input is pulse, then what is the happening. So first he will tell the procedure how to do the power divider, and then he will excite with the equal power division and unequal power division. So Vivek, kindly please.
Okay, now first we have for power division, Wilkinson's power division, we have to go for the RF. In that generic RF components, I am selecting as a Wilkinson's power divider. Then I have to mention all the details of that one. Here the impedance will be 50. Then effective permittivity should be 3.3. Then this center frequency should be 2.4 gigahertz, and k right now I'm keeping k as 1 only. Length will be like 10. Then this k as 1.
K
Okay,
is basically your coefficient of coupling. So three equal coupling requires the K is equal to 1, right?
okay. Now
Length of segment.
length of segment will be 10 for input and output both right now. Then I will connect the circuits with the different components like resistance. Here I am connecting a resistance to port 2, then another resistance to port 3. Here I will give one input source, one input resistance along with the input voltage source. Okay, now what I will do is just connect the circuit R3 to P1, this R3 to a voltage source, then this P2 to R1, then this P3 to R2. Now I will connect all the grounds over in the circuit. This one will be connected to a ground, another ground will be connected over here, then will be another ground will be for P2. Sorry. Okay, this one more ground will be connected over here to P2, and then one more ground to P3, and voltage source. Now the circuit is complete. Now I have to give the complete values for the all the resistance. This one will be a 50 ohm, then R2 R1 will be a 50 ohm, then R2 will be 50 ohm, and now I will decide the values of a voltage source. Will give a input sinusoidal voltage source. Here just I have to change the frequency, which will be at 2 gigahertz. Okay, now the circuit is complete. Then we'll check what outputs we are getting. We'll go to a test palette. We'll go for a transient. In that we are doing basic test setup. I will enter the values from 0 nanosecond to 5 nanoseconds, similar to a previous one. This one will be a 10 pico, and step ceiling will also be a 10 pico. Now we'll do a preset graph. First of all, we have to select, check the nodes, what nodes we are exactly having. 1, 2, 3. We have to check the outputs for V1, V2, and V3. V1, V2, and V3. We'll add those into the edit block list. Now we'll run the overall analysis of this Wilkinson's power divider. What output we are exactly getting, we can check. Now I have to go for a single graph, and we'll check through tracker what exactly output we are giving input and what output we are getting. See, this one is the input what we are giving at the port 1, and this one is the output what we are getting V2 and V3 at port 2 and port 3. From this graph you can check that these powers are divided equally into port 3 and port 4, and the phase is same. Okay. Now one more this exactly proves that okay, power divider functionality. Now again we'll come back to our circuit diagram and will show that how unequal power distribution occurs. So this is one PDF we are having in which it is shown key Wilkinson's divider with the unequal power split. For that we have to check this load impedances that exactly depends upon our K value what we have given over in this one K value. Over right now we are selecting the K value as 2 will keep, and we'll check what output for load impedance we should select. Like load impedance ZL1 will be root K of Z0 means root 2 is equal to 50. Output will be a 70.71. And for load 2 it will be Z divided by root K. 50 by root 2 is equal to 35.36. Then we'll change accordingly over the outputs over here. This one will be 70.71 and the other one will be 30.36. Okay, now we'll okay, this one will be 70.71 and this one will be 30.36. Now again we have to do the same test, just we 35.36. Okay, now again we have to do the similar test. It has exactly shown over here, just we have to calculate the voltages over different parts. Now we'll again run the test. Just a second. K here I have mentioned K is equal to 2. Okay, now this voltage is 2, this will be 2. Okay. Okay, so we are here we have put the values of 70.71 and 35.36 according to a value of your K equal to 2. Now we will run we have to preset the graphs and check the values for power ratings. P1, P2, P3 will add, and we'll remove this part right now. Okay, we'll check the values of the power. See the exactly value how the power is getting unequally divided, not in the equal parts. We can check by going to a tracker part. This one is the input power. Sorry, this one is the input power what we are having right now, P3. Okay, and this is how the power is getting divided at port 1, R1 resistance R1 and resistance R2. Okay, here the resistance values are different, and see the power level is unequally divided right now. This one is 1.5 and this is directly to 3. Okay, approximately 3. So you can check the values accordingly and see how so this shows that with the value of K there will be an unequal distribution in the power level. Now also I can check one more thing I can show you over here. Just go to a circuit part. Now I will decide just the value. I will keep it as it is of load impedances 50. Here I will keep as it is 50. Now my K value is different one. K is 2. Okay, what I will do is preset graph plot. I will check the voltages at that part. Okay, what voltages we are getting. Okay, see here also we'll get different voltages. There is an unequal distribution of voltage. This one is the maximum what input we are giving, and we are getting a different voltage at depending upon the value of K at port 2 and port 3. You can go to tracker and check it once again that this is the input voltage, this is the output voltage at port 2, and this one is at port 3. There is an unequal distribution. There is no change in phase, but there is a change in amplitude. Okay, so this exactly shows the functionality of a power divider with this circuit and the RF Spice software. Okay, thank you.